And here we have this lovely 3x3 system solved by using any method. So when I take a look at it, one thing that I notice is this has x and this has negative x. So if I add those two equations together, those two are going to cancel. So that would be good news. Before I do that, I think I'm going to get a red pen, and I'm just going to label this as equation A, B, and C. So what I was saying is if you add equations B and C, then this x and this negative x are going to cancel each other out. Those will be gone. And then when you add the y values, 5 and 3 makes 8y, and negative 4z and negative 1z makes negative 5z. And on the right side, a negative 19 and a negative 9 equals negative 28. Okay, that wasn't so bad. Now I'll go back to the equations, and I used B and C, so now I need to use two other ones, and I also have to get x to eliminate again. So I noticed that if I look at this one and this one, if I just multiplied C by 2 and added it to the top equation, then the x's will cancel. So then next I'm going to do 2 times C and then add that to equation A. So 2 times this will be negative 2x. Added to that, they cancel. That's good. Next up, go 2 times C, so that means this is 6y, and added to this leaves 5y. So we've got 5y. And then go 2 times C, so 2 times this will be negative 2z plus a positive 3z, leaves positive 1z behind. And then finally, for the constants on the right side, if you multiply this by 2, that's going to be negative 18, and add it to 17 equals a negative 1. All right, now we have two equations that have only y and z, so we could use whatever method we want. I think because it's easy to solve for z, I'm going to use elimination method. So I'll leave the z there, and then subtract 5y from both sides. So z is equal to negative 5y minus 1. And then take that and substitute it in to the top equation. So then the top equation will become 8y minus 5 times, and then replace the z with the negative 5y minus 1, and then that equals negative 28. And just like that, we've almost found out what y equals. So I just need to distribute. So we've got 8y, and then negative times negative will be positive 25y. And then negative 5 times negative 1 is positive 5, and that still equals negative 28. So when you combine the y terms, an 8 plus 25 is 33y, and then just subtract 5 from both sides, and a negative 28 and a negative 5 is negative 33. Oh. So that means that y equals negative 1. So divide both sides by 33, y equals a negative 1. And then I can just go back to this friend right here to find out what z equals. So substitute the y as negative 1. So z will equal negative 5, and then y was a negative 1, and then minus 1. And there, we're done with that smiley face. So let's see, that's going to be a positive 5 minus 1, so z is equal to 4. All right, we have 2 out of the 3 answers. Now we just need to find out what x equals. So go back to the original equations, clean this up a little bit, and which one looks easiest to use? I guess the bottom one has the smallest numbers, so I'm going to use the bottom equation. and then substitute what we got for y and what we got for z. So it's going to have negative x plus 3 times y was a negative 1 minus z, and then z was a 4, and then it equals negative 9. And what's that? Negative 3 and negative 4, and then it equals negative 9. So it's negative x minus 7 equals negative 9. And then add 7 to both sides. So it's going to say negative x equals negative 2 from negative 9 plus 7. And then finally, multiply both sides by negative 1. X is equal to 2. And then finally, for my answer, I'll put it as an ordered triple. So x goes first, 2. Y was equal to negative 1. And z was equal to 4. And there, we're done.